I'm Kate with Iris Dynamics, and today we're controlling an Orca motor directly from a Windows PC. Setting up the Orca motor is very easy. We have the motor connected to a 24-volt benchtop power supply. The motor data cable is plugged into an Ethernet splitter, and then the RS422 cable is plugged into interface 2 of the splitter. The USB end of the cable is then plugged into the computer. Both an Ethernet splitter and properly crimped RS422 cable are available in the Orca motor starter kit. Please note, when force or position commands are given, the motor should be secured, as it will move suddenly and quickly. In this example, we have written a C++ program which uses our Orca API to communicate with the motor. More information about the Orca API is available on the downloads page of our website, linked below. By using API commands such as set position, we can command the motor to move to a specified position. By using commands such as get force and get temperature, we can easily display the status of the motor beneath the plot. The motor functions as both an output and an input device, meaning it can exert force on a load while also sensing the force being applied back to it. We have used the Iris Controls API to create this motor plot GUI, which can be easily customized for specific applications. Our software development kits include pre-built GUIs, which allow you to start moving a motor right away. In this example, we have created a quick C# simulation project in Unity and are using a managed wrapper around our Orca API to communicate with the motor. The program uses the getForce function to sense the amount of force being exerted on the shaft. That same force is then applied to the virtual gears. This means that if a stronger force is applied, more force is applied to the virtual gears, and so they move faster. Are you starting a new project? Our skilled and friendly team is here to help. Contact us today to see how an Orca motor can support your application.